Assalamualaikum. My name is Nur Adila binti Muhammad Adlan from CS 1115C.
Hi, Assalamualaikum. My name is Puteri Elmira Azarin binti Muhammad Jafiza.
Assalamualaikum. My name is Anis Naziha binti Ahmad Rozi.
Hi and Assalamualaikum. My name is Nur Sarah Adriana binti Syamsul Anwar.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatah binti Rahim.
So we are from CS 1115C and under Group 2. We are going to present the forecasting the number of dengue fever cases in Hong Kong, China.
Content. Number 1, introduction. Number 2, literature review. Number 3, methodology. Number 4, result and analysis. Number 5, conclusion and recommendation.
Chapter 1, Introduction. In recent decades, the dengue epidemic has dramatically increased globally. Dengue virus is a very serious and the most common disease in the world that is transmitted via the bite of female mosquito in the species of Aedes. The dominant species and a vector of dengue virus, Aedes aegypti, originates in Africa and is well known as a species of mosquito that can transmit yellow fever virus, chikungunya virus, Zika virus, and other viruses. Therefore, dengue has been recognized in more than 100 countries and usually occur in America, Southeast Asia, the Western Pacific, and East Mediterranean regions. Dengue also can be widespread throughout the temperature, humidity, rainfall, and rush increase of unplanned urbanization. All that health workers can do is to keep the patient hydrated and prevent dehydration by giving the patient a lot of water to consume. In Hong Kong, the city that has a warm temperature and humid summers reported dengue fever, a statutory notifiable disease in March 1994. Rapidly, the Department of Health starts to investigate the source of dengue viruses. In September 102, Hong Kong faced the first locally acquired case of dengue fever, which included a 21-year-old patient who presented with pyrexia, thrombocytopenia, and headache. Thereafter, the number of dengue virus infections begin to escalate as the years go by. The trend shows an increase because of Hong Kong in the process of making the city an urban region that causes a lack of rubbish disposal, inadequate water and waste. The effects of increased urbanization lead to mosquito population dynamics, as the weather variables like temperature, humidity, and rainfall is ideal for the breeding of Aedes mosquitoes. In Hong Kong, a new characteristic of dengue is analysed in 2019. It was stated that most cases happen in China. For example, the indigenous cases that have happened in 2019 were in Sichuan, Hubei, and Chongqing. According to an article from the Health Government of China, in 2019, the dengue fever has a higher rate of infection in China, not only in terms of number, but also in terms of geographic spread. The characteristics of dengue fever such as spatio-temporal and crowd features. Nevertheless, there are many new characteristics that have yet to be discovered by previous researchers. As a result, it is critical for residents to be aware of these new characteristics in order to prevent the spread of the dengue virus. Research objectives. There are 3 objectives in this research. First, to analyze the pattern model of data about the number of dengue fever cases in Hong Kong, China. Second, to identify the most accurate model for the number of dengue fever cases in Hong Kong, China from January 2008 until October 2021. Thirdly, to forecast the number of dengue fever cases in Hong Kong, China from November 2021 until March 2022. Research question. First, how to analyze the pattern model of data about the number of dengue fever cases in Hong Kong, China. Second, what is the most accurate model for the number of dengue fever cases in Hong Kong, China from January 2008 until October 2021? Third, what is the expected number of dengue fever cases in Hong Kong, China from November 2021 until March 2022? Significance of the study. Forecast the number of dengue fever cases in Hong Kong, China for upcoming years is the significance of this study. This is because, depending on the forecast, the government can take various alternatives to flatten the cases of dengue in Hong Kong. Scope of the study. The study focused on the number of monthly dengue fever cases which take place throughout January of 2008 until October 2021. Forecasting will be carried out in this study using the secondary data provided. Limitation of the study. Factor that can impact the research of this study is the limitation that will be faced by researchers. As in this study, the researchers are using the secondary data. It might have limited information to the study and have no control over the data. Thus, the researchers are only carrying out the study based on data provided. Moreover, since it is secondary data, the accuracy of data may be unreliable.
In this chapter 2, I will explain the literature review of the article or journal related to our studies. Firstly, using the naive method. There is research on the situation of dengue fever in Thailand, and the objective of the study is to forecast the number of dengue hemorrhagic fever cases that will occur within a 7-day interval in the next 1 to 4 weeks by utilizing the data that were gathered from external sources. The forecasting result using naive and moving average method seems to be good. Next, a study from 2019 shows there is another method that is better to use rather than using naive methods. The objective of the study are to develop the right method for forecasting dengue. Standard time series analysis methods have been used to estimate the parameter values from the limited amount of data if it used multiple sources. The study from 2021 shows a seasonal, naive, and naive are not the accurate approach if the series contain high lumpiness value. In this study, the average method is the best method because of the high uneven value. The objective of the study is to forecast dengue in Sri Lanka using a time series forecasting approach. Based on these 3 studies, it shows there is another method that is more suitable to do the dengue forecast rather than using the naive method. Secondly, the literature review using moving average method. There have been some studies about forecasting dengue fever cases using the moving average method. Having said that, there is a study of dengue fever in Queensland, Australia in 2009, which concluded that observed value in the validation dataset were consistent with the expected value from the moving average model. Next, there is a previous research using the same method in 2019, suggesting that every year the data is statistically associated with official dengue records and follow a linear time series trend, and it is necessary to identify relevant data behavior. Furthermore, another study shows that the most suitable baseline model to use to forecast the dengue fever outbreak in Thailand is using a naive and moving average model based on the researchers' result. Based on the evidence from other researchers in 2019, using the moving average methods imply that this method is not suitable to use in fluctuating data pattern because in their expected analysis of mean absolute percentage error is very large, indicated that the accuracy rate is very low. Another study data stated rather than using the double moving average method, the trend method has more benefits and is more suitable to use as there is a significant gap between the actual data and the predicted result shown in the pattern chart. Thirdly, literature review using the single exponential method. Single exponential method is one of the exponential smoothing techniques. This technique was one of the methods that the researchers always include in the forecast study due to the accuracy and minimal assumption. However, there are only a few studies that use exponential smoothing on dengue fever contacts. Based on a study done by researchers in 2016, single exponential method has been chosen as the best model to forecast the time series for dengue cases in Kota Baru due to the method having the lowest mean square error value. Next, another study shows that forecasting by using this method is the best model for forecast the spread of dengue fever cases. Even so, based on the accuracy level, the exponential smoothing forecasting approach is still less precise. Other researchers in 2020 said that if the data does not show a trend or seasonal pattern, the single exponential technique is appropriate for modeling. Nevertheless, the single exponential method will not be applied to predict future dengue cases as there is a seasonality in the series. Other than that, researchers use a single exponential method in the research to detect mosquito population search in order to undertake mosquito prevention and control action. And the researcher found that using the single exponential method is better than other technique. Furthermore, based on another study in 2018 shows a 55% of data accuracy. However, the researcher recommend using other forecasting model as this method might be less precise. Next, literature review using the double exponential method. From a previous research carried out by the researchers on dengue fever, the method of double exponential used to forecast the case. The gathered data from January 2010 to August 2019 is used to forecast the value for 3 months afterwards. In this research, a lot of other forecasting methods are used, and one of the methods is the double exponential method. Yet, this method is not relevant to use. This is because the Borg-Pierce test shows the dependency of autocorrelations. Another research in 2018 of the analysis of dengue cases conducted in two regions which are Selangor and Wilayah Persekutuan showed that double exponential method is not suitable for forecasting. The comparison made from MAPE, MAD, and MSD indicate that Holt's winter method is a better method than double exponential method. The study from 2017 shows double exponential smoothing and Holt-Winter method are suitable for forecasting the dengue cases. The objective of the study is to analyze dengue cases in Penang by using a time series approach. The comparison between the two methods shows that double exponential smoothing is more suitable to represent dengue cases in Penang as a result of the lowest values of error measurement. Other study from 2016 shows double exponential smoothing and Holtz-Winters method is the better model to forecast the dengue cases in Johor. The similar methods are used with the study from 2017, and the objective of the study is to analyze dengue cases in Johor, Malaysia. However, results from the study indicate that double exponential smoothing is the best model than Holtz method. Last but not least, literature review using Holtz method. Many researchers use Holt method in forecasting data because it allows users to smooth the time series and use that data to forecast areas of interest. From a previous research paper, the researcher attempted to fit dengue fever time series into a few models. The data consists of 16 observations that were taken from 2014 that were collected from Malaysian Open Data Government Portal. There are several types of Holtz method that have been used by the researchers such as the regular Holtz method, Holtz with exponential trend, damp Holtz, and damp Holtz with exponential trend. From the other study, the objective of the study is to forecast the value for 3 months from June to August in 2019. The data taken is from one of the unit of Ministry of Health, Sri Lanka from January 2010 to May 2019. Other research paper, the researcher used the double exponential method and Holt-Winter method to analyze the data and forecast the future pattern of dengue cases. The data gained from two different states which are Selangor and Wilayah Persekutuan in this study. The researcher adopted 3 main numerical assessments to compare each model's performance. The best fitted and predicted value is observed from the lowest value of each of the error assessments. The NAT research that was conducted by MSc Research Project in Data Analytics used Holt-Winter to analyze the data that was collected from 2010-2017 from 15 states in Malaysia. The researcher used Holt-Winter function from the R package to compute a Holt-Winter filtering for data from 2011 to 2015. Next, other research used a data taken from 5 countries which are Singapore, Taiwan, Thailand, Brazil and Mexico, then use Holt-Winter seasonal model as the best model and vary input parameter to generate multiple other models.
Chapter 3 Methodology. Understanding the data. Data was obtained from Hong Kong's government official data websites. The information was gathered monthly from January 2008 until October 2021. The data is about dengue fever cases in Hong Kong, China. In this study, virtually all of the data used were obtained from Hong Kong's government official data websites and generally available to the public. The data is then analyzed using quantitative forecasting such as knife models, method of average, and exponential smoothing techniques. Data partition. Data used in this study is 166 data in total, where it will be divided into partitions with a ratio of 70-30. 70% of the data covers the model, while 30% for the evaluation. The partition of the data is shown in the table. Model used for the data. There are two models used for the study, which are moving average methods and exponential smoothing techniques. Under the moving average methods, we have average focus model, average change model, and also average percent change model. Under exponential smoothing techniques, we have single exponential smoothing, double exponential smoothing, and also Holt's method. The first model under moving average method is average forecast model. Assuming that the forecast value is equals to the average value of the data divided by the time period of the collected data, this method need to be recalculated the forecast value each time a new observation is succeeded and added to the existing series. These are the formula of an average forecast model. Average change model. This model is widely used by organizations as its firmness and achievability. The forecast value to the actual value in the current period and add to the average of the absolute change experienced up to the point in time. These are the formula of average change model. Average percent change model. This model is different from the previous model because it is considered that the forecast of the independent variable equals to the actual level of the variable in the mean time period, add with the average of the percent change from one time period to the next period. This is the formula of average percent change model. The first model from exponential smoothing technique is single exponential smoothing. Single or simple exponential smoothing needed only one parameter, which is smoothing constant alpha, to get the fitted value and the focus. It is the simplest form of model among other exponential smoothing techniques. The focus for the next and all subsequent period are determined by adjusting the current period forecast by a portion of the difference between the current period and the current actual value. These are the formula of single exponential smoothing. Double exponential smoothing. Illustrating a linear trend criterion by using double exponential or Brown's method is useful for the series by using the following notation. St is the exponentially smoothed value of yt at time t, while s prime t is the double exponentially smoothed value of yt at time t. At evaluates the difference between the exponentially smoothed value, while bt evaluates the adjustment factor. Ft plus m is forecast for m step ahead made at point in period t. Holt's method. The value obtained from the previous method, which is double exponential smoothing, are sensitive to random influences, and to control this, Holt's two-parameter method is used to overcome the data with linear trend. This technique comes up with more flexibility in choosing the rates at which the trend and slopes are tracked, and by using distinct smoothing constant, can smooth the trend and slope directly. These are the formula of Holt's method. Types of error used to compare the model. In this study, we use three types of error measure, which are mean square error (MSE), root mean square error (RMSE), and lastly, mean absolute percent error (MAPE). The first error measure is MSE, mean square error. It is used to measure the average of the squares of the error, which is the average square difference between the estimated values and the actual value. This is the formula of MSE. The second error measure is root mean square error, RMSE. It is the standard deviation of the residuals. RMSE is commonly used in climatology, forecasting, and regression analysis to verify experimental results. These are the formula of RMSE. The last error measure is the mean absolute percentage error, MAPE. It is used to measure the accuracy as a percentage and can be calculated as the average absolute percent error for each time period minus actual values divided by the actual values. These are the formula for MAPE.
Chapter 4, Results and Analysis. Based from the linear graph of actual number of dengue cases in Hong Kong, we could see that the pattern of the cases is rising and falling. The most highest cases was found in August 2018 and August 2019 with 40 cases each. Due to the summer season in Hong Kong during August, the temperature recorded exceeds 30 Celsius. This increasing number of cases may also related to the seasonal factor due to the rainy season. Next, for the model outcomes. The first model outcome is the moving average model. The linear graph shows the consistent fitted line with a value of 7.1566. Moving on, for the number of cases using the average change model, the fitted value showed the highest value in September 2018 with a value of 51.5000, where rainy season occurred and it contributes to the rising number of dengue cases. For the average percent change model, the pattern of the fitted value showed a dramatically increasing number of cases in May 2014 with a value of 113.7500. This is also due to the gloomy and rainy season that happened, and it was said that the dengue spread is affected by the changes in the rainfall. For the first model outcomes for the exponential smoothing techniques, which is the single exponential, it was found that the fitted line is gradually increasing over the year and the highest value is in November 2019, which is 17.7504. Due to the rainy season, it has encouraged the growth of mosquito as well as the spread of dengue cases. Next, using the double exponential method, the fitted value recorded the highest value of 16.9856 in December 2019, where the weather is cool and dry temperature. Due to this weather, it has contributed to the spread of the dengue cases during that month. Lastly, using the Holtz method, the highest fitted value is 17.4144 in November 2019. That also happened to be occasional showers, heavy rain and thunderstorm which increased the humidity level and temperature that causing the high number of dengue cases. For the estimation part, the data used for the error measurement of MSE, RMSE, and MAPE is only 70% of the secondary data. Based from the table shown, the smallest value of both MSE and RMSE was found using Holtz method with a value of 21.0357 and 4.5865 respectively. While for the MAPE, the smallest value is under double exponential method with 65.9317. Next, for the evaluation part, the evaluation part only take 30% from the data, where it was found that the least error is using average change model, where both value of MSE and RMSE is 55.3938 and 7.4427. While for the MAPE, the smallest value found using average forecast with 53.5229. Since the evaluation part is used for forecasting for the future number cases, we are going to use average change model since it is the best model due to the least error. Lastly, for the forecast value, the best model used is the average change model where the forecast value for number of cases is 0 from November 2021 until March 2022. It is also supported with the updated number of dengue cases by Hong Kong's government. Since December until January is winter season, it makes sense that the value is 0 because of the Aedes mosquito cannot survive during this weather. This might also due to the impact of COVID-19, the movement control is implemented. That might be the reason why the sudden decreasing number of cases also found in the data.
Conclusion and recommendation. Conclusion. The first objective to reach is to analyze the pattern of the model using the data gathered. It can be concluded that the pattern of the data is moderately increasing by year and there is a sudden increasing number of cases but continue to decrease until the recent year. The second objective is to identify the most accurate model for the number of dengue fever cases in Hong Kong, China from January 2018 until October 2021. One of the criteria of the best model is a model that can evaluate good forecast value persistently. The researcher needs to compare the output for each model based on the error measures, which are MSE or MAPE. The model that generates the smallest value of MSE or MAPE will be chosen as the best model. After the evaluation for each model completed, the researcher found that the smallest value of measurements error are by using MSE that are obtained from the average change model, which are 55.3938. Thus, for this study, the average change model are the best model to analyze the data. The last objective is to forecast the expected number of dengue fever cases in Hong Kong, China from November 2021 until March 2022. By using average change model, expected number cases for November 2021 until March 2022 is 0. It happened because the weather on that time is winter. Aedes aegypti mosquito cannot live in winter because of the cold environment. The climate change can assure the dengue cases decrease. Recommendation. First, the first suggestion is to use the updated data. The researcher only able to find the data until October 2021. It is suggested to the other researcher to find the most updated date at least a month before. This is because the more updated the data, the more accurate the result. Number 2. The outcome of forecast the occurrence of dengue can be beneficial for some relevant authorities as a rough plan to be prepared for. It is intended that by having an effective planning could halt the spread of dengue fever by increasing the readiness to identify, describe, and control the growth of dengue virus as the dengue virus has no specific treatment. Number 3. It is suggested to not use MAPE because it is not valid for every type of data. This error measure only relevant for ratio scale data only. When the actual observation has a value close to 0, MAPE potentially explosive for large forecast error. Therefore, it is suggested for the future researcher to not apply simple percentage type measures to a situation where denominator is small because they tend to grossly exaggerate errors in the forecast.
That's all from us. Thank you for watching. Bye.